Hello guys, welcome to another grand interesting video on your Leansimcorp channel, and in this today's video we are going to continue our part 3, okay, where we are going to analyze a case study for a random industries company, and we need to meet a target demand of 675 parts per day. So in the part 1, we created a simulation model which was creating a replica for a real case studies for a random industry with its problem statement where they were not able to achieve 450 bottles per day. Okay. Then in part 2, we analyzed the system, identified the bottleneck in the system, and we debottlenecked it. And then we find it out that now random industries, by making these changes to the system, can achieve 450 bottles per day, that is 22 pallets, okay, can be achieved. But now the target demand is 675 bottles per day, which has to be achieved by random industries, and for that we are now going to find out the solution. And if possible, we would be finding out what is the minimum buffer required in their system. Okay, so now I'll just run this and show you our previous system where you can see that we are able to create 49 parts where the target was 450 parts per day. It's almost cut down. And if you could look into this, is that you're going to get in the next bottleneck into the system is ST4. Okay. So if I just see what we are going to get in is like show names. So if you see that ST4 is going to be the bottleneck station, and that is nothing but the combiner where we are going to combine a bottle with a cap is going to be our bottleneck station. Okay. Now before that, let us have one of the graph that is to identify the cycle time of the station. Let us identify the cycle time of the stations. Okay, and what we're going to do is we're going to select the processor and the combiners, right? And let us reset and run and see if we could get an idea of what is the cycle time station. So if I look for ST1, where the average cycle time is coming to be 3.1, I wanted to get the minimum cycle time. Okay, so I wanted to find out a graph which can help me to get the minimum stay time onto the system. So if I just click on this, and if I just pin this and say I pin it here, let us take at a histogram, and we have a histogram in what? Do we have any properties here? Okay. Here we are having the same thing. Okay, so basically you can see the average stay time which was spent by the item onto these all particular stuffs. Okay, so we will be getting an idea that STC1 has a highest time, then ST3, then ST4. Okay, the stay time. So now if you could look at though, our ST4 is 99.59% utilized, right? And then we are going to have the cycle time as 3.20 as there. And when we look in for STC1, which is 33% utilized, the stay time stays out to be most probably the average time comes to be 3.02. That is the palletizer. And we see for STC1, that is the cap forming thing, it is basically going to have a stay time of what is this? Basically the minimum of 3 minutes, maximum of 3.21. But that is because we are weighting the things onto the system, as we are not getting the line or we are not getting the bottles from this bottling line. So this is basically staying onto this. So if you see, it is almost blocked for 66%, even though the stay time looks to be higher for STC1. It is not the cycle time of it because it has to wait, as I'm not getting the bottles onto the plate. But the cycle time for my bottling thing was 1 minute. So now what we have able to visualize into the system is ST1, 2, 3, okay, and 4 basically are going to have almost ST3 and ST4. ST3 and ST4 are the most highly utilized stations. So the moment I'm going to debottleneck ST4, my next bottleneck is going to be ST3. Okay. So now what are we going to do? If you look at for ST4, the cycle time is 3 minutes. Okay. And if I look in for ST3, that is 2.5. So if you remember, we were discussing that we are going to need 2 operators here, reducing the cycle time to half, or we need to have a cycle time improvement from 5 minutes. Then only you are supposed to get your demand per day. But to achieve your target forecasted per day, which is 675, let us see what has to be done. Okay, so now we find it out that these 2 are the stations which are the bottleneck into the system. Okay, so now what we are going to do is the cycle time of the station is 3 minutes. If we are supposed to be improving the cycle time, okay, to 2 minutes, okay, you will see that my ST3 is the bottleneck. Okay, so if you see, my ST3 is now a bottleneck, and I am basically producing 26 pallets, which is 538 pieces, per day. But as now ST3 is the bottleneck and the average cycle time comes to be 2.67, let me make this 2 as well as 2. Okay, and if I reset this and run this, what we are going to see is that my ST4 and ST3 are going to be the next bottleneck station together, along with my ST2, which is the highly utilized station. Okay, and if you see, our target is 675 and we are achieving 673 pieces with 33 pallets per day. Okay,